In this first problem, you're given the exponential function y equals 255 times 4 to the x power and are asked these questions to identify if it's a growth or a decay function, what the initial value is, and what the constant factor is. And really, A and C are related to each other because you need to know what the constant factor is to be able to know if it's a growth or a decay function. Matter of fact, a lot of times they'll either call the constant factor a growth factor or a decay factor, depending on what kind of function you have. So when you look at 255 times 4 to the x, it is a growth function, and we'll explain why in a moment. The initial value is always the constant being multiplied to the exponential. The exponential is the one that has the variable raised in the exponent area. So it's 255. But it's the constant factor and the fact that this is over 1 that tells you it's a growth. And it's because it's 4 in this case, it is a growth. Meanwhile, when you look at the next one, y equals 400 times 3/5 to the x, this one would be a decay function. And it's because you have an initial value of 400 and this constant factor, which would be a decay factor at this point, because this is a value that's under 1. So 3/5 would be the exponential factor of this function, or the constant factor. When you consider looking at graphs, you're often going to be looking to come up with the equation of the functions. And sometimes as you get to lower ends of this, and depending on the scaling of the graph, it might be hard to tell what's going on with the functions. Sometimes you try to take your guess, but once you see what the pattern is and you're told it is an exponential function, you have to basically trust the pattern more than trust any value that you may have interpreted based off of what is plotted here or what it looks like it is. So for instance, as you look at the possibilities for this, this is definitely a decay function. It is moving down as x increases. So that alone would tell you that each one of this one's a growth, and this one, even though it's a fraction, it is over 1, it would be a growth. This is a decay. So really, the only one that's going to make sense is this one here, but to confirm that that is indeed the actual formula, making a table of values here, this one looks like it's at 0.16, that looks like it's at 112, that's at 2.9. This one looks like it's at 4.5, but it's actually, you're going to find out it's close, but not quite 5 exactly. Because as you look at this, as you increase by 1, this is decreasing by 4. This is decreasing by 3. This would be decreasing by 4 again. So it doesn't look like it's a linear pattern for certain. It doesn't even look like anything that's a constant thing going on. However, if you look at each one of these being a multiple of the other one, or some constant being multiplied, 12 is 3/4 of 16, 9 is 3/4 of 12, and here you're progressing by 2, so you would really be doing 3/4 squared times 5, which would give you about 5.0625. That's why it looks like it's at 5 exactly here for a y value, because the scaling of the graph here, you know, a 0.0625 being more than that's not going to make a big difference. So, but you have your initial value right here when x is 0 at 16. You can see the constant factor of 3/4, so that does verify that that is indeed the correct equation. And likewise for this one, you can rule out the first one being a possibility because this is growing as x increases, and this would be a decay function. The rest are showing constant factors that would indicate growth. So this one's out for sure, the top one. Now as you look at the values here, each one of these grid lines here is going by 1. So this looks like it would be at almost 0.1, but it's really kind of between 0 and 1. So this might even be a half in the long run. 1, 2, 2.8, and 3.32. Those are more definite points on this one, looks like. So let's see what's going on here. And sometimes you do have to kind of experiment to see like which one it is. I mean, because your initial value is certainly going to help determine which one you're choosing. You see, none of these seem to have an initial value that's 1. So each one of these is increasing by 1. If you look at, again, differences or multiples, this one seems to be multiplying by 2, but the rest are multiplying by 4. So this one doesn't seem to be quite right, and it kind of goes with the fact that it's actually a little bit under 1. So when you look at it, it's more 1/2. If that starts at 1/2, then you would have the constant multiple of 4, and that's what's really going on here. And so at 0, you're at 1/2, so your initial value is 1/2, and you have a constant multiple of 4, so that's your 4 to the x. So it's this bottom one down here, that's the choice. For this, all it's asking you to do is to calculate the y values given this formula, and it basically is just making sure that you're substituting the exponent in correctly. So when you do 24 times 1/2 to the negative third power, keeping in mind that you're reciprocating the 1/2, that's what the negative's doing, so you're actually doing 2 cubed here, that's why you get 8, and 24 times 8 is 192. And you would do the same for the rest of these. All the negative exponents are going to be showing reciprocals. That's why you're seeing like this is flipped and squared, this is flipped. To the 0 power is 1. For here, you're just going to multiply by 1/2. You're going to multiply by 1/4. Here, you're going to multiply by 1/8, and that gives you these values here. And likewise for this one here, a growth. So these will increase as you're going along here. So I always start with the 0 one, because sometimes it's a little faster to fill it in, because 625 times 5 to the 0 would just be the 625. And if you don't want to keep plugging formulas in, keeping in mind that you have a constant multiple of 5, as you move into bigger x values, these should increase, which means you'd be multiplying by 5. And that would give you these values. Whereas if you're starting in this position and going in this direction, you'd be dividing by 5. Each time you're moving up the list. And so that would give you the 125, 25, and 5 here. And that would be another way of filling in a table like this. And so that is the end of this problem, and that is the end of this video. If you have any additional questions, please make sure to bring them up during our class session.